Okay, so this is all your homework with the correct answers, and I'll kind of talk you through some of the problems. Number one is growth, and the reason I know it's growth is because of the 5 greater than 1, it's growth. Number 2 is growth because 6 over 5 is the same as 1 and 1/5, greater than 1. Number 3 is decay because of the 3 over 8 is less than 1. Number 4, the parent function is just 4 over 5 to the x, and the transformation is it moved to the left 2 because of the x plus 2. If we think about those being in parentheses, then it's going to do the opposite of what we think. So if it's plus 2, it moves to the left 2. For number 5, the parent is just y equal 2 to the x. It's been reflected over the x-axis. We know that because of the negative sign in the front. It's moved to the right 1, where we can see that where it says x minus 1. That lets us know it's been moved to the right 1. Vertical stretch of 3, if we see that 3 out front, and then it was moved up 7. Okay. Number 4, there's the graph. I graphed it on my graphing calculator, and I transferred that to the graph. The domain is all real numbers. The range is y is greater than negative 7. I think that looks more like negative 7. For the end behavior, as my x values go toward infinity, my y values go toward infinity. As my x values go to negative infinity, my y values approach negative 7. There's your y-intercept, and I've shown the math work right here about how I got the y-intercept. I plugged in 0 for x. If I plug in 0 for x, that's the number I get, negative 6.89. And the asymptote is at y equal negative 7. For number 7, that's what the graph should look like. We notice because there's a minus 3, look where your asymptote is at, y equal negative 3. Domain is all real numbers. Your range is y is greater than negative 3. And then you can see your end behavior. Y-intercept, and I got my y-intercept again. I went up here, and everywhere there was an x, I plugged in a 0. That took me to right here. I put this in my calculator, and this is the correct answer. Number 8, there's my graph. And the domain is all real numbers. The range is y is greater than negative 6. Are you kind of picking up on being able to look at the equation and see what the range is going to do? I hope so. The end behavior, as your x values get larger, so as we go this way, as they approach infinity, your y values approach infinity. As your x values go this way, your y values are going to approach this negative 6. Your y-intercept is 0, and then negative 5.5. I'll show right here where the negative 5.5 came. So we can plug in 0 for x, and your asymptote is the line y equals negative 6. We're not. Y is equal to 1/8 times 4 raised to the x plus 1 power. The range, the domain is all real numbers, and the range is y is greater than 0. Your end behavior, as x approaches infinity, y approaches infinity. As x approaches negative infinity, y approaches 0. Your y-intercept is at 0, 1/2. Again, plug in 0 for x. Got to here. You can either do that out by hand or plug it in the calculator, and your asymptote is y equals 0. Notice if your equation doesn't move up or down, like if you don't have a number out here, plus or minus, your asymptote is at y equals 0. For instance, here on number 10, it ends with a +1, and our asymptote is at y equals 1. And here's the graph for that one. And to get the y-intercept, I plugged in 0 for x. Anything to the 0 power is 1, and so forth, and you end up with 5. And then the last one, plug this one into my calculator. Domain, all real numbers, your range is y is less than 5. As your x values get larger or go toward infinity, your y values go to negative infinity. As your x values go to negative infinity, your y values are trying to approach this number right here, which is 5. Your y-intercept, I didn't show it this time, but the way that you would get it is plug in 0 for x. You get a result of 4.6, and your asymptote is the line y equals 5. If you need to access an online graphing calculator, you can either Google graphing calculators, you should come up with something, or you can always go to desmos.com and you'll be able to get a graphing calculator.